This video will discuss what happens when a quadratic is not in standard form, and in particular, how do you solve them, how do you find their roots. There are 4 different ways that we can solve quadratics that aren't in standard form, and it's really kind of 4 different situations you might see. The first situation is that a quadratic is not in standard form because it's not arranged correctly. In particular, you see an equal sign in the middle, not all the terms are together. If this is the case, the easiest thing to do is just to convert it to standard form, which means that you need to get all of your terms on one side, or you need to solve for 0. One way to do that is to move the x squared over. I would prefer actually to subtract 3x and subtract 10, because that's going to allow x squared to stay positive, which just makes it a little bit easier for me to solve. So the purpose of subtracting is to cancel everything out over here so that we get 0. And then on the other side, we end up with a quadratic equation that we're used to, which is x squared minus 3x minus 10. And this is now in standard form, which means all those strategies from the last video apply. You could quadratic formula, or you could factor this. This one's pretty easy to factor because you can probably even do it in your head. This is just x minus 5 times x plus 2, which means that the solutions, when you split them out, are x equals positive 5 and x equals negative 2. Now, you won't always be able to factor these, of course, but if factoring doesn't work, you know that you can use the quadratic formula. Here's 2 for you to try. Pause the video while you solve these, and then when you press play again, I'll show you the answers. Here are the answers. Notice that we had to use quadratic formula for the second one. The second possibility of a quadratic that's not in standard form that we might have to solve is a quadratic equation that looks like this. And you'll notice right off the bat that this is kind of out of the ordinary. In particular, it's only got 2 terms. And it's pretty important at this point that you know your definitions, because it does matter which term is missing. Because you could actually use the snowflake method to factor it, or you could use quadratic formula, because when you're missing a c value, we've got a and b, really it's just a 0. So if you wanted to, you could think of it as a 0 and then set up your snowflake. What I'm going to show you is a shorter way to find the solutions, though. And the shorter way is to recognize that there's a greatest common factor. Because both of these terms are divisible by 3, and both of these terms are divisible by x, you can pull out an x. And when you can pull out these 2 terms, in other words, I can rewrite this function as 3x times x plus 4. This is actually a factored form, just like using the snowflake method would find factored form. This is factored form itself. The way that I got this term inside, if anybody's wondering about that, was just kind of to think backwards. Once I realized I could divide these by 3 and by x, I thought to myself, well, what do I have to multiply times 3x in order to get 3x squared and 12x? We know that in order to find the roots, we want this to equal 0, which means either 3x must equal 0, or x plus 4 must equal 0. And when I solve those 2 equations, I divide by 3 over here, and it tells me that x either equals 0, or subtract 4, x equals negative 4. And those are my 2 solutions. Here are some practice problems that are like example 2. Please pause the video while you solve these, and when you press play, I'll show you the answers. Here are your answers. Again, pause the video while you check your work. Be especially careful on the last one, which turns out to have a fraction answer. When you press play again, we'll talk about the next possibility. One thing worth being careful with are equations that look like this. And at first glance, this might actually look kind of similar to what we did a minute ago. But what you should notice, the difference is that this last term doesn't have an x. So this is actually not a b value. This is a c value. It's a constant, which means we're missing b, which should have been in the middle, the coefficient of x. We don't have one. Again, you could just assume that b equals 0, and you could do factoring, or you could do quadratic formula. But the truth is those things are going to get pretty messy because you have some big numbers, and there's an easier way. In this case, you only see one x value. The easier way is going to be to use the square root method, which is the third and final strategy we have for solving quadratics. Again, we know that finding the roots means I want this equation to equal 0. So my first step is just to set that up. Now, the other thing that I know, if I focus on my goal, is that roots, well, they look like x equals. So I want to come down to a place where I've got x by itself, and usually there's two of them. And I can see that x is pretty close to by itself. It's being squared, and I'm going to have to somehow deal with that. I'm also going to have to deal with the 2 and the 40. So let's handle the easy things first. It's easy to get rid of the 2 and the 40. We can just subtract 40. And then we can divide by 2. And now I've got x squared equals negative 20, which is really close to what my answer should look like if I could just get rid of that 2. And the good news is that you can. It's real easy. You just take the square root of both sides. And when you take the square root of x squared, it's like that symbol and the exponent cancel each other out, and you end up with x by itself. And then the other important thing to remember is that when you take the square root of a number, for example, negative 20, there's always going to be two square roots. One's going to be positive and the other is going to be negative, and that has nothing to do with this negative inside. This negative inside turns into an I, because the square root of a negative is I. Meanwhile, 20 is the same thing as 4 times 5, which means the square root of 20 is 2 root 5, and I tack on an I from that negative. That's the first solution. The second one is exactly the same thing except it's negative, and it's going to be negative 2 root 5i. And those become my two roots, which are my final answers. Couple things to be careful with. Using the square root method doesn't mean you have to have an I as your answer. The reason I have an I is because this happened to be a negative number. You won't always have that. Also, using the square root method doesn't necessarily mean that I'm going to have a square root in my answer. I have a square root in my answer because I ended up with a number that I couldn't easily simplify. If you get a perfect square at this step, your answer won't have a square root symbol in it, and that's fine. Here are some for you to try. Pause the video here to work these out, and then when you press play again, I'll show you the answers. Here are the answers. I'm going to try and zoom in for you. The last type is another instance where we can use the square root method. The only difference is that we have parentheses in the original problem. And I'm going to just show you an example here and point a couple things out. The process is the same. The goal is to get the parentheses by themselves so that we can take a square root. We first get rid of the 8 and the 2. And then after you take the square root, the only last piece is to get x by itself, in this case by adding 3 on both sides. Take a moment to look at this example, pausing if you need to, and then try these. And when you're ready to see the answers, press play again. Here you go.